Hello students, today we're going to be talking about the distributive property. This is the fifth math property that we did not get to yesterday. So in your table of contents, go ahead and write down the title of our notes, distributive property, and this will be page 111 in your math binder. Make sure that you are keeping your math binder organized so that you can utilize these notes should we have an open note quiz. So when looking at our notes, at the very top here, they give us an example. And it says each student below simplified the expressions as shown. So we have Miguel, who has taken 6 times the quantity of 3 plus 9. He added 3 plus 9 in his parentheses and then multiplied 6 times his answer of 3 plus 9, which is 12. So we all know that 6 times 12 is 72. And then Elise had the same type of problem, okay, but instead she had her 3 and her 9 separated. So she had 6 times the quantity of 3 plus 6 times 9. She solved her 6 times 3, which is 18, and then added it to the solution of 6 times 9, which is 54, getting the same answer, 72. Francis, instead of having a 3 in his problem, he had a value of x. So Francis has 6 times x plus 6 times 9. He solves 6 times x, which is 6x, plus 6 times 9, which is 54. And now we're asking ourselves, if x equals 3, will Francis's solution be the same as Miguel's and Elise's? So if we were to plug in the value of x as 3, that would mean that our 6x is 6 times 3 plus 54, which we know 6 times 3 is 18, plus 54 would also be 72. Okay, so they all would have gotten the exact same answer. So I want you to go ahead and write yes. We know that when 3 is substituted for x, then Francis's expression is going to be the same as Elise's and also equal 72. Okay, so you can just go ahead and write yes. If x equals 3, Francis's solution would be the same. We know that this is true because we plugged in the value of x as 3 into the problem, and we got the exact same answer as Elise and Miguel. Okay, so those were 3 different ways of solving the same problem. Now, farther down in your notes, we're going to go ahead and define what the distributive property is and why we use it. So the distributive property allows us to multiply each term inside parentheses by the number outside of the parentheses. Algebraically, we would say A times the quantity of B plus C would equal A times B plus A times C. Okay, same thing if we were subtracting. A times the quantity of B minus C would be A times B minus A times C. So you are just distributing your number outside of your parentheses to the first number, multiplying them together, hanging onto this sign, and then doing the same thing with your second number. Multiplying the number outside of your parentheses with the second number inside of your parentheses. Okay. Be careful with your signs when multiplying integers. So your positive and negative signs. Okay. So let's go ahead and practice this. Each of the 4 members of the Robinson family ordered a drink. D, represents a drink, 2 slices of pizza, P, and an ice cream cone, C. Distribute and write an expression to represent their order. Okay, so we know that the drinks have a variable of D to represent drink. The 2 slices of pizza, 2P, represent the pizza. And our ice cream cone is represented by the variable C. So if we were to distribute 4, being the members of the Robinson family, who each bought a drink, 2 pieces of pizza, and an ice cream cone, our expression to represent their order would be 4 times D plus, because I have plus signs here, plus 4 times 2 slices of pizza plus 4C, 4 ice cream cones. Okay, you could then solve this part right here to instead get 4D plus 8 slices of pizza plus 4C. So again, we're just distributing the number outside of our parentheses to the values inside of our parentheses and multiplying those values together, hanging on to our addition signs as well in between each value. Okay, further down for question number 2, it says use the area models below to distribute. So if we were using the area models here to distribute, this would be 5 times the quantity of 3x to get this area right here. And then you would also do 5 times 2 in order to get this area here. Okay, so our solution would be, our problem would look like 5 times 3x plus 5 times 2 in order to get the value of this whole box here. Okay. When solving this, we know 5 times 3 is 15, so that would become 15x plus 5 times 2, which we know is 10. And that would be our expression in order to find the area of that model. For B, same concept. In order to find this area right here, we would do 7 times x. So that would become 7x. And then we would do 7 times -9. And we're adding because we're trying to put both of these values together. So you would be adding them together. So this would be 7 times -9. So when solving that, this would become 7x plus, I know 7 times 9 is 63. One number is positive, one number is negative, so this would become a -63. You could put parentheses around that to show that that's a negative number. All right, y'all. Go ahead and put this notes page in your math binder and get ready for your next rotation.